Hi everyone, welcome again. This is going to be a hands-on video on Spring Data JPA. Let's see what we are going to cover. So for this video, we'll have an existing MySQL database. Why an existing MySQL database? Because most of the time while working on a project, we don't create databases from scratch. We already have a database, some tables, and we need to build something around those tables. So that's why for this demo, we have an existing table and an existing database. Then we'll create a Spring Boot project and we'll add Spring Data JPA support in that project. After that, we'll use that Spring Data JPA support to insert some records in the same table. And after that, we'll read those records. So let's get started. To create a new Spring Boot project, I'm going to use Spring Initializer plugin in my IntelliJ, but you can do the same thing using web version of Spring Initializer. So let's create a new project. I'll select Maven, language is Java. Then I'll change the group. Name of the artifact, Spring Data JPA demo, and the same name here. Java 17 is fine because this is LTS. Hit next. Invalid package name. Oh, this one. So let's name it main. Yeah, here we will add the dependencies. We are going to work with MySQL database. So let's start by adding the MySQL driver dependency, then JPA, Spring Data JPA. That's it. Hit next and hit create. This will create a new Spring Boot project with MySQL as its database driver and Spring Data JPA. If we open the project and check the pom.xml, we see all those details. So we see the starter dependency for Data JPA, then MySQL connector because we are going to use the MySQL database. And this is resolving the dependencies. This is downloading the Maven dependencies for the same. In the source folder, we have resources, application.properties, which is right now empty. And in the Java, we have the main class, which is annotated with @Spring Boot application, which means this is a Spring Boot application. So let it resolve the dependencies and then we'll start adding the code to read and write from the database. Now that the dependency resolution is complete, let's check the database. For that, I'll go to my workbench, and here this is the database, the existing database, Spring Data JPA demo. And in this database right now, we only have one table with the name user. So this table is empty. If I run this query, select star from this user table, then we see no records, but we see the columns. So there are 5 columns: ID, name, email, registration date, and active. And if we check the table structure, then these are the columns. Active is of data type bit, which is used to store the Boolean values, true, false, which shows that if the user is active or not. Registration date is of type date. ID is big int, and this is also the primary key of the database. Email and name are varchar. So this is the table we are going to use. Now we need to write some code using Spring Data JPA so that we can insert some user records in this table, and later we will read the same records using Spring Data JPA. So how do we work with this one? Let's go back to the project. First of all, because we are talking about the ORM features, object relational mapping, that's why we are using Spring Data JPA. We have one side of the mapping, which is the database table, in this case, the MySQL table. The second side of the relationship is an entity, which represents the Java class or the object that we will be working with. So we'll create a new entity in our project with name user that will be a Java file, and then we'll start adding the properties in that Java class, and we'll start with the mapping of the properties with the database table. Let's go back to the project, add a new package. We'll store all the entities in the entity package, and I'm going to add a new class here, user. This user class will have different properties that we will map with the database columns. So if we go back to the database again, we have 5 properties: ID, name, email, registration date, and active. So let's add those properties here. Private long ID, private string name, private string email. This is name, yes. Then registration date and active. Now registration date column is of type date in the database, but in the Java side, we'll use the local date from Java 8. So local date, we name it registration date. And the last column is active, and the data type of active column is bit in MySQL, and we know that we want to store the Boolean values. So this is going to be a Boolean property, active. And then we'll generate the getters and setters. For all the properties like this. Let's also add that toString using all the values, and we need to add a default constructor. Hibernate demands that the entity must have a default constructor or no argument constructor, and then we'll create another constructor to initialize the user object. Here we don't need to include ID in the constructor because ID is something that Hibernate will automatically generate. It is the primary key of the table which is going to be auto incremented. All right, so we have the user class. Now we need to map this class, this object, to the table. To do that, we use the annotation @entity. And notice that we are using the entity annotation from this package, jakarta.persistence. That's why we say this is Spring Data JPA. The entity annotation on any class will tell Spring Framework and Hibernate that this class is mapped to a database table. So Hibernate will check the properties of this class to find the mappings between the properties and the corresponding database columns or the table columns. Notice that we have not mentioned the table name. We have only used the entity annotation. By default, what Hibernate will do, it will use the name of the entity to find the table name by converting the class name into the camel case. So in this case, the name of the table will be user, which matches this name. So that's why we don't need to specify the table name explicitly. Coming to the ID, which is going to be the primary key, and this is mapped with this column. So we need to tell Hibernate by using the ID annotation again from the jakarta.persistence package that this property is going to be our primary key. And another annotation generated value. Now generated value tells Hibernate that I'm not going to provide you the primary key or the ID attribute. You need to auto generate the value. So Hibernate will auto increment the ID value when it inserts the data in the table. All right. Then comes the name, email, registration date, and active. Because all these properties match as far as the name is concerned, so we don't need to use any additional annotation or property or any other configuration. This is more than enough. All right. Now that we have configured the entity using all the appropriate annotations, let's provide the details of the database to our application. To do that, we'll use the application.properties file. Here we will define the database related properties. So first of all, we'll use spring.datasource.username. And in my case, the username is root because I'm using the root user. So that's the username I'm going to provide. The next property is spring.datasource.password. And in my case, this is this one. So you need to provide your username, database username, and database password. I'm providing mine. The third property that we need to use is the URL of the database. Now we need to provide the URL where the application would find the running database. So this will be my database URL. So this is the name of the database that we are using for this project, and it is running on my local host with port 3306. These three properties are required in order to connect to a database. There is one more property that we need to configure, but that is just for the investigation purpose. So we'll say spring.jpa dot showSQL equals to true. That means whatever Hibernate is doing, we want Hibernate to log that SQL in the logs so that we can see what's going on. That's it. Now we have the database details and the entities, but how do we talk to the database? For that, we need a repository. So we'll create a repository here. To do that, first let's create the package, name it repo, and in this one, we'll create a new class and we name it user repository. Now Spring Data JPA provide many default implementations of the repository so that we don't need to write the basic CRUD operations. And it must be an interface like this. And this interface will extend another interface, CRUD repository. If you see, this is coming from the Spring Data. So we need to extend this CRUD repository where the first type parameter is the type of entity, in this case, user. And the second parameter, the type parameter, is the type of data type of the primary key. So if we go back to this entity class, this is long, and that's what we need to provide here, user. That's it. So we created the entity, then we created the user repository, and we are extending CRUD repository, which is coming from the Spring Data. And we provided the type of the entity, which is user, and the data type of the primary key. And that's the only thing we need to do. So we create the interface and the implementation is generated by the Spring framework at runtime. And because we already defined this user repository, let me just tag it with repository interface. This is the required condition. Otherwise, Spring doesn't know about this repository. Now we have the user, which is the entity, the repository, and the database details. Let's move on and add the final piece, how to run this application. To do that, we'll create a bean application runner just to run the code once the server is up or the application is up. And like this. And we need user repository, so we'll define that here. So when we run the application, before Spring Boot completes the execution of run method, it will see that we are using application runner bean and we are passing user repository. That means this bean has a dependency on this repository bean. So what Spring Boot will do, it will check if it has the user repository bean, which it has because we have defined it here. So it will inject that bean to application runner, and whatever code that we write in this block will be executed by this Spring Boot. So here we can write the insertion logic. To do that, we'll initialize the entity user. Let's name it user1. And we'll use the constructor. Let's name it name, email. What are other properties of this user? Name, email, registration date, and active. So for registration date, we say local date.off, year 223, month 7, date 1, and active, which is a boolean, so let's say 2. Once we have the user, we need to save it. To save it, we use the repository that we created, and we'll use the method save. Now if you notice, all these methods are coming from the CRUD repository, because if we go back to the repository, we have not defined any method and we have not provided any implementation. But all these methods are coming from the CRUD repository, and the implementation will be provided by the Spring framework at runtime automatically. We simply need to call the save method, pass it the entity, in this case u1. That's it. Now when we run the application, it will create a new object and it will use user repository to save this object. Due to the annotations that we used, Hibernate knows that it needs to persist this object in the corresponding table. So it will insert a record in the database. Let's run the program and check the output. So here we got an error that user-sequence does not exist. This is because if we look at the entity, we are using @generated value annotation on the ID property, and we are asking Hibernate to auto-generate the primary key values. But to do that, it needs this sequence table which does not exist in the database. So here we only see the user table. Now we need to tell Hibernate, we need to allow Hibernate so that it can create the missing tables automatically. To do that, we'll add a new property here, spring.jpa.hibernate.ddl-auto. Now the possible values are, let's say, create, update, none, and so on. We need to provide the value update because we don't want Hibernate to drop everything and create the schema from scratch. We already have this user table and we don't want to touch it. We simply want to create missing tables. So that's why we are saying that update the schema if you see something missing, but don't drop and create everything from scratch. And this time, if we run the program, this is running again. And we see that here we see the queries executed by the Hibernate. This is because we are using this property show SQL. So that's why Spring Framework is able to dump this information in the logs. So here you can see that Hibernate is executing this query, create table user sequence, because that was missing earlier. And then it is inserting the data in the user sequence to maintain the auto-generated values. So that's fine. But the important thing is, if you see when we called the save method on the repository, what Hibernate did, it triggered an insert query in the user table. And if we check the database, run the select query again, we see the record inserted into the table with ID 1, name that we provided, with the email and the registration date. And notice the active column in the Java side, this is Boolean, but Hibernate is translating the Boolean values appropriately to 0 or 1 according to the data type. So we inserted the record successfully. Now let's read the data back from the database. We already have the entity with all the required annotations. We have the repository. We'll use the repository methods to find the record, to read the record. And this time we'll say find by ID. And we'll pass the ID 1 because that's the ID in the database. This must be long, so long dot value of 1, like this. And find by ID returns an optional. So we say that if it's present, then print the user record. Let's run the program. So in the logs, we see that Hibernate inserted a new record again with the same details, and that's what it would do because we are using the save method. So if we check, we will see two records with different IDs. But notice that for this method call, it triggered a select query like this and passed the ID 1. And that's why we see this output. If you notice, the ID is 1 because we are saying that trigger find by ID, fetch the record by ID. And if you find the record, which is handled in the Java side by using if present method on the optional, if you find the record, then print it. And because we have toString method present in the entity, we see a nice output on the console. So let's quickly rewind what we did. We had a table, an existing table in the database. Then we created an entity like this. We used the annotation on the ID attribute and then on the table to map the table with this entity. Then we created the user repository, tagged it with @repository annotation, extending CRUD repository so that we don't have to write common CRUD operations, and it will be generated by the Spring framework. In the main class, we created the new objects, same as what we generally do in Java. The difference is to save the record, we are using now user repository, calling the save method, passing the entity that we want to save, and the implementation of this save method will be generated by the Spring framework. So notice that we have not written anything. We are not managing the database connection or the statements. Everything is done by the Spring. And then to fetch the record back from the database, we used another method from the repository, find by ID, passing an ID value and printing the value if present. So that's how simple it is with Spring Data JPA. In this video, we covered the basic details to insert the data and to read the data. That's it for now. Thanks for watching.